Hey guys, we're going to finish up 7.5 today. Kind of get thinking ahead to a quiz on Friday for 7.4 and 7.5. The next week we'll probably have a test over all of Chapter 7. So kind of keep that in your brain as we're going along. So, we did applications yesterday about a wagon and a lawnmower being pulled or held on a ramp. Today we're going to talk about navigation. So some of our bearings that we did earlier are going to come into play. Okay? We're not going to get too crazy in depth, but we're going to talk about what's happening. So I'm on example 4 on page 346 if you want to follow along. A ship leaves port on a bearing of 28 degrees and travels 8.2 miles. The ship then turns due east and travels 4.3 miles. How far is the ship from the port? What is its bearing from the port? So as we draw that, remember our bearings. If somebody's leaving on a bearing of 28 degrees, where do we always start our bearings? Yes, due north. And that line's not really there. We always start with due north. And a 28 degree bearing is just 28 degrees from due north. Okay, and then it traveled 8.2 miles. Now they put 8.20 because they want 3 sig figs. Okay, so that's going to come into play. And then they turn due east. So east is just going to be a straight across line. And they traveled 4.3 miles. Again, they leave the 4.30 for sig figs, right? Now they're asking, how far is the ship from the port, from our beginning? So we put a P there for port. Can we figure that out? Of course we can. The first thing we're going to do is, well, if here, this has to be 90 degrees, correct? So what is 90 minus 28? And we get it is 62 degrees. So on the outside, on this side is 62 degrees. Because 62 plus 28 has to be 90, plus 90 gives me 180 in that triangle. Okay? So that means this inside angle, we're going to take 180 minus 62 to get 118 degrees. Okay? So if we want to know how far, what are we looking for? The ship is from the port. Oh, we're going to pretend those landed at the same time. We're going to find that distance right there. What does that look like? We have a side, an angle, and another side. Can we use the law of cosine? X squared equals 8.2 squared plus 4.3 squared minus 2 times 8.2 times 4.3 times cosine of 118 degrees. Okay? So we're solving this. I'm plugging this in my calculator. 8.2 squared plus 4.3 squared minus 2 times 8.2 times 4.3 times cosine of 118. And it's approximately 118.8, etc., etc., etc. Plug that into my calculator. And I'll get approximately 10.9. It would be miles, right? That is my X. Approximately 10.9 miles. They want those 3 sig figs. Okay? So now the next question they asked is, what is the bearing from the port? Meaning, can we find what this angle is right here? Okay? Because we need to add it to that 28. Okay? But we have to find this little sliver of green that I've drawn green here. Can we do that? We now have an angle and a side opposite it. Angle. We're looking for an angle and a side opposite. We're going to use the law of sine. Exactly. So we're going to use 4.3 over sine y will equal 10.9 over sine 118. I'm going to cross multiply and go in this direction. 4.3 sine 118 divided by 10.9 is going to equal sine y. This is going to be some decimal, approximately, let's see, 4.3 sine 118 divided by 10.9, 348, etc., etc. Second sign, second answer, I got 20.38. So y is approximately 23.4 degrees. Okay, that is this piece right there. 23.4 degrees. But is that the angle it is? Is that the bearing? No, because remember bearings we want from due north. Okay, so I need all of it. I need 28 plus this 23.4. I'm sorry, that's not 23, it's 20.4. Oh my goodness. I cannot, read today. This is the second time this has happened to me today. I'm sorry. It wasn't 23. You're saying, hey, Miss Evans, in my calculator, it was 20.38. It was 20.4, 20.4 plus 28. There we go. It's approximately 48.4 degrees is the bearing from the port. Okay? All right, let's do another one. Maybe I won't mess up my numbers. All right, here we go. A ship leaves port on a bearing of 25 degrees and travels 61.4 kilometers. The ship then turns due east and travels 84.6 kilometers. How far is the ship from the port, and what is its bearing from the port? Okay, so here we go. A ship leaves the port. Oh, I don't want to be in orange anymore. Sorry. Leaves the port on a bearing of 25 degrees. So my north is here, and I'm going 28 degrees. Maybe make it a little bit more. Sorry. It's 25 degrees. The last one was 28. 25.0 degrees for 61.4 kilometers and turns due east. Which way is east? You have to know this. I have to know this. Due east is going this direction. West is going the other way. So it's going due east, and it travels 84.6 kilometers. Okay, kilometers. So now it's asking, how far is it from the port? Okay, and what is the bearing from the port? Okay, so we got to figure out a few things. Well, there's lots of stuff here we need to figure out. We need to figure out an angle and a side opposite. So really, I need to know, what is this angle up here? Question mark. No, I don't want to put another X. Let's put a question mark, it's fine. Well, by due north and due east, they have to hit at a 90-degree angle. Yes, they do. So what is 90 minus 25? That's 65. So this angle right here is 65 degrees. Because in this little triangle, I'm just going to kind of do here, must be 180 degrees. Okay? So if we have an angle and we're looking for the side opposite it, can we find it with x squared equals 84.6 squared plus 61.4 squared minus 2 times 84.6 times 61.4 times cosine of 65 degrees. Okay, now I've got to plug all that in my calculator. 84.6 squared plus 61.4 squared minus 2 times 84.6 times 61.4 times cosine of 65 degrees. And I get 6536.5895, etc., etc., etc. Take the square root. X is approximately 80.849. So 80.849. kilometers. That is my x. It's right here. 80.8 kilometers. All right, next. Wait, 65, okay. Here we go. What is its bearing from the port? Meaning, really, what is this angle from the port? It's going to go all the way from our due north, all the way around to here. Okay, so how are we going to find that angle? Well, if we had this part, we would know the others. Okay, we could know what the whole thing is 360 if we knew that little piece. Okay, so the question is, how are we going to find this angle? Do we have a sine? Well, the question is, do we have an angle, 90 degrees? We don't know what that little piece is. Could we find how far this is? And then we would have this distance. We could find that distance. Is that doable? Or we could just use the 65 and find this distance. It's up to you on what you want to do. There's several different ways to go about it. I think I'm going to do it with sine 65 over y. I'm going to find this height equals sine opposite over hypotenuse. I don't even need sine 65 equals opposite, which is y, over hypotenuse. Since it's a right triangle, I don't need the fraction. That's it. If it's a right triangle, so y will equal, we're just cross multiplying, y equals 61.4 sine 65. Okay, now I'm going to plug that in my calculator. 61.4 sine 65. Y equals 55. It's approximately 55.6 kilometers. So that is my height. 60, oh my goodness, it's 55. I'm writing things wrong. I'm sorry. 55.6, that is my height here. Okay? Can I find this angle? I'm really going to use cosine of adjacent over hypotenuse. Does that make sense? If I want this angle right here, I have the adjacent, I have the hypotenuse. So can I say cosine, unknown, cosine question mark, equals 55.6 over 80.8. Okay, just 1 second. Got to plug that in my calculator. Inverse cosine of 55.6 divided by 80.8. And this angle right here is 46.5 degrees. Okay? So now the question is, what is the bearing that the ship is on from the port? Okay? Remember, they're always from due north. So my north is up here. From here, all the way around. So I want 360 to find the angle. I'm going to say 360 minus that 46.5. And that will be, it's on a bearing of 313.5 degrees. Yes. All right. Are we good? I think we are. We found the distance it is from the port, which was here, and we have the bearing it made. It is from the port, okay? Are we good? Yay! We're going to have a few problems. I think we're going to be done for today. And then we'll review 7.5 problems. We are going to keep it simple and just have a few. So we're going to do 1, 3, 7, 8, 15, and 16. All right, you guys are the best. We will see you again later. Bye.